Right, an introduction to Carlo Gavazzi's Dupline field bus. So what is it? What is Dupline? Well, it is a field bus, but it's a protocol, and we use it for a variety of applications. It's always been necessity, and we develop a new solution for the necessity. But I'll share with you some areas that we have been very successful. One is in mining and quarrying, if that's a word. Aggregates, I think, is the better word. But we have within Dupline a true SIL 3 safety bus. I'll talk a little bit more about that. We use it in building automation for everything from HVAC to access control and lighting. We have a decentralized lighting control system, including tunable white light, and we'll talk about that a little bit. It's also a great SCADA system, which may touch a little more of what your customer base is. And due to the nature of it, we have used it successfully in a variety of SCADA applications, from water and waste all the way through agriculture. It's a very extremely adaptable system. We have an irrigation component for this, and it's especially suited for, say, small, 5, 10, 15 acre organic farms, small orchards. It's people in that market segment are forced to either buy an overkill product that's designed for a large farm, or they have to go consumer level and buy like a Rainbird, and both are not the right fit. So we do have a niche market for irrigation using Dupline. We have more than 10,000 doors under control in prisons and jails using a Dupline solution, and there's so much more. As I mentioned, its first iteration was all the way back in 1986, when it was still Electromatic, before Carlo Gavazzi purchased Electromatic, and it has continued to evolve. And in 2015, we made the jump between what I now refer to as legacy Dupline, the old stuff, and smart Dupline, which is an entirely new suite of technologies and products. And our latest things I'd just like to share with you. Globally, we have almost 200,000 installations using Dupline. We have quite a few in the United States, so I don't want you to get the idea this is just a European product that we're trying to push into the US market. Dupline is in absolutely thousands of installations around the US and Canada and Mexico. Some things that it does, even though it's a proprietary system, we have just a huge number of gateways that allow us to communicate over BACnet, over Modbus RTU, Modbus TCP/IP, Ethernet IP. So it is, by that very fact, an open protocol as well. Now, it was designed for extreme noise immunity, which makes it an industrial grade network. It's extremely robust, and it's used in rock quarries and oil rigs and some really tough applications. Some new things that we're doing today and where we're headed, there's a really neat product called tunable white light that basically the color temperature or the frequency of light, it has been discovered at many peer-reviewed studies that one end of the spectrum will cause the human body to produce cortisol, a hormone that's part of the flight or fight or fight or flight, I always get those mixed up, system. And so by moving the light to a certain frequency, it tends to put people on point. This can be used, say, first thing in the morning for school children. Just change the color temperature and they're ready to learn. At the other end of the spectrum, the body creates melatonin, which has a more of a soothing effect. So we do have a full white light offering now. We also are in the process of releasing fire damper controllers. We have secured the proper UL listings for that. So we will be releasing those this summer. They're ready to go now. It's just we're waiting for this COVID thing to move on. And we are, if you keep track of Industry 4.0 and smart cities, most of those are designed to work over a protocol, which is low power, long distance, LoRa, and the LoRa one. And we have several products that allow us to operate on those frequencies. So we're continuing to invest. Instead of showing you all the products first and then talking about where we're used, I thought I would, kind of switch it up a little bit, show you some of the areas that we are used today. One, we're used in oil rigs. And the reason we were used in oil rigs is that weight is a real problem, just like it is on any marine vessel. And we were able to reduce the wiring bundles in oil rigs by 80% by deploying Dupline, which its first design was as a wire reduction system. So this happens to be a company called Rowan in Houston, Texas. And this is the North Sea, where this one happens to be. I think that was Gorilla 7 or 8. I mentioned jails. We are, like I say, 10,000 doors and counting. We are in state facilities. We are in federal detention centers. And there's also a large market for private prisons out there. So we're in that as well with companies like Geo. Lighting control. This is Hershey Park, and they installed some time ago a Dupline lighting control system for their parking lot. It's pretty simple, but it just shows you the breadth of where Dupline can be applied. This is a famous application that we did, floating bridges. We have several. The most famous is the one in Seattle. And essentially, these bridges have floats or pontoons, and they tend to accumulate water in the bilge, just like you would on a boat. So we're detecting the presence of water. We're operating the pumps, and we can also, level the bridge. Some of the pontoons can be partially flooded. So it is a full control system, and Dupline, including Carlo Gavazzi level controls, play a part in this. Tunnel boring machines. We went through about a 10-year period. The market is pretty much owned by a company called Robbins. I think they hold most of the patents on tunnel boring machinery, and they've had a standard for using Dupline, and now Dupline's safe in their tunnel boring equipment. Sometimes it's not economically feasible to retrieve the tunnel boring machine, so they just leave them at the end point. It's very expensive, but anyway, we're used extensively on below ground boring. Parking guidance is another area that Dupline is used. And you may have seen systems, they're very common at airports and hospitals, where you have indicators above the spaces or in the drive lanes that move you to the open spaces. We make a system like that. We make several, and we do quite well with it. And we're installed in places. We're in the transit centers in Southern California, Johns Hopkins Medicine, Cancer Treatment Centers of America. There's a number of these, and this is our newest. It's Car Park 3, if you're wondering. I don't know if this is your business, but I wanted to show it as an application. One, it's been around a long time. It's up in Bill Ralph's territory, our control of track heaters, primarily for Amtrak, but also for SEPTA, which is the Southeastern Philadelphia Transit Authority, and some others. But this is still where on a rail they have a chase where you can actually move conductors. Since they have to bring the power, it makes more sense to use a hardwired solution. We're starting to get into wireless now, but this is a hardwired. So what is Dupline? Like I said, originally in 1986, it was developed as a wire reduction system. You can have 128 conductors reduced to 2 wires. So that was the big draw, and that's what launched us. We do so much more, including wire reduction. It's become more of a control platform. Some things about Dupline: has a completely free topology. You can do a ring, a star, a bus. You know, it's really very forgiving. The only thing is that the solder connections need to be good, and they need to be, if they're outdoors, they need to be watertight. That's the only stipulation. So there's only 3 main components in a Dupline system. No matter how elaborate, it will always have these 3 components. First, you have a channel generator, and the channel generator is a character generator. What it does, Dupline works on a time splice multiplexing system. And what that means is it basically, if you will look at the, say a Dupline header, you always have a synchronization pulse, and then each address, and you have 128 addresses in standard Dupline or channels, A1 through A8, all the way down through P1 through P8. So each of these is a 1 millisecond pulse. Now, let's say I have an input connected to the Dupline at A2. When that input is made, it causes this 1 millisecond to now change to 0.75 and 0.25. So when it pulls low, it's working between 8 and 8.2 volts DC. When it pulls low, then it sees that as an actuation, and it's really pretty simple after that. But it has a slow clock speed of 1 kilohertz, and this gives it amazing noise immunity. I've seen these installed in control conduit, and there's never a problem. I don't recommend it, but it's not a problem. Now, in our world, transmitters equal input modules, and there's all different form factors. These are just 3. We have a multi-channel DIN rail. We have decentralized, which this is actually has the length and width of, say, a postage stamp, and it carries 4 inputs, so it's really small. You can embed these. Then we have other, like I say, other form factors. They can be digital. We also have a full analog complement of 0 to 10, 0 to 20 milliamps, but also we have embedded temperature sensors that provide an analog input. So you can deploy these, say, for HVAC or for agriculture, food processing. Some are loop powered, like this one. Means it draws its power directly from the Dupline bus. So it's really great if you just need a switch closure and you're 500 feet away. You don't have to run power. And this is a nice feature. So I mentioned transmitters equal input modules, receivers equal output modules. Just like the transmitters, there's all different form factors. Here we see the decentralized relay. Here we see a multi-channel. This is a 4-channel relay. You know, so and we can do customs too. We've designed things that just make sense for an application. Again, we can have digital or analog, and some are loop powered, as I mentioned. So we talked about addressing in a Dupline system. This is not a programming class, it's just an introduction. But I think this is important because we can visualize this on a matrix. You have channels 1 through 8 and groups A through P. There's a P down here, trust me. It's just cut off. So this gives you a standard 128 addresses. Now, Smart Dupline has closer to 150. It depends on the burden on the network. But just for this discussion, we'll keep it at 128 so we don't confuse things. And the way it's addressed, if you have a background in PLCs, this will seem counterintuitive, but we can have a one-to-many arrangement where I have one transmitter. Let me get my laser pointer. There we go. Look at that. So we can have one transmitter to many receivers. So flip back, we have 128 addresses. Now, this is an A1 coded input. Now, the receivers, I could code 1,000 receivers is A1, and that's only one address because we're dealing with addresses. Whereas in a PLC and ladder logic, they would call that a coil duplication, and it would not be allowed. But we can do one-to-many and many-to-one. So this is really great. Let's say you have, and this is the way our Dupline safe works too. Let's say you have multiple motors on a conveyor. You have one E-stop switch. So the E-stop switch would be coded the same as the output modules at the motors. So the E-stop would de-energize all of the motors at once. So, you know, so you would not have to have actual control wire between each one. It would just be done over the Dupline and the local power supply. So one-to-many, many-to-one. 128 addresses as a little summary, and you can have many devices only equals one address if it's all coded the same. Now let's talk about a very popular Dupline system, and that's Dupline Safe. And Dupline Safe uses the same technology with receivers, transmitters, and channel generators. But it has a monitoring component that allows it to have SIL 3, safety integrity level, for those of you who don't know what that means. And number 3 is the highest safety integrity level that a bus system can be awarded. So it has an international standard, so it's accepted with any application requiring this. The main application is long conveyors. Long conveyors can be miles and miles. We did one with Nucor Steel in Charleston, and they use they're near the water, but they pretty much work with recycled steel. So the barges would come into the dock, they would load those onto a truck, and the truck would bring them to the plant. Well, they decided to build this 3-mile conveyor from the plant to their own dock. So now the barges load directly onto this long conveyor. So the efficiency rating went up, the cost went down doing this. But all along the conveyor, whether it's a mining conveyor, which would fall under MSHA, or if it's an industrial conveyor that would be used, say, for steel scrap, for pulp and paper is another one, that falls under OSHA. But the requirement for both is that a conveyor has to be guarded completely to prevent a human from falling onto the conveyor. and being carried away, or it must have safety pull cord switches, which are large limit switches that work as an e-stop, and typically you will have a safety switch and everything's wired in series. That's one way to do it, and that's been the way to do it. However, there's some inherent problems with that. When that switch is made, you don't know where it's made because it's just one big series connection. Somebody pulls a physical wire or a wire rope and it shuts down the conveyor. It does its job, but where did that happen? Imagine, you have a 3-mile conveyor, it's 2 o'clock in the morning and somebody pulls an emergency stop. What do? With the Dupline safe, each input module that's installed with the pull cord switch gives an exact location. So this data, this information can be sent directly to a phone or to an annunciator system. The other problem, without a system like this, and you just have a safety relay with pull cord switches attached to a rope, is that you can have ground loops. And what ground loops will do, they will actually render the switches inside of the ground loop invisible to the system. So someone could pull the rope and it wouldn't see it. So ground loops are a real concern in this world. And the Dupline being it's a monitored bus system. Every cycle they're looking for this module, and it has to send back an "I'm okay" signal, or it shuts everything down. It fails safe. So those are the two problems it solves. Now, a bus is typically tied to a safety PLC, which makes it extremely expensive. Ours is not. Our system, let me advance a slide here, maybe I can show you a little better. Our system is self-contained. It has a safety receiver, and this handles the monitoring. So each one of these safety transmitters or input modules are installed inside of a pull cord switch housing. And each one of these, and you can have up to 63 safety transmitters per receiver. Each one of these are monitored every cycle. And if it's offline, or if it's in a make state or break state, then you will cause a safety. This has 2 internal force-guided safety relay contacts to de-energize the load. So that's how we achieve that rating. This is a housing of a safety switch. This is our transmitter. It is a normally closed device, and it is small and it's sealed, and it's designed to really stand up to the elements, but it's installed inside of the housing for the pull cord switch. So imagine these all along, and here's the wire rope if you can see that. There's actually a mistake. It's 3.1 miles is the distance without a repeater, and we can add repeaters to this. So you can conceivably have 10 or more miles. Each transmitter has a unique address for that application I mentioned. You know exactly where the pull happened. And we communicate either Modbus RTU or Profinet or Profibus to a PLC. The PLC has nothing to do with the safety circuit. It is there only to receive information. So that's the difference. There are safety PLCs that bring the safety PLC into the SIL3 type bus system, but they're hideously expensive. This is not so expensive. And if all you're using the PLC for is to monitor or to pick up the alarm status, you don't need a safety PLC. So this is what makes this so attractive. The other thing is it uses standard 14 gauge wire, and there's no special connectors. whereas on other systems, some are done on like the Aussie bus or whatever, very short runs without repeaters, very specialized cable, very expensive cable with special connectors. We don't have any of that. Another application, we did 2 of these this year, and we've done probably a dozen over the years, but at airports, aging infrastructure, they have emergency shutoff requirements at their fuel loading facilities. Whereas the fuel truck pulls up and they dispense it to the fuel truck. If there is any type of a situation that requires an emergency fuel shutdown, excuse me, the FAA requires that a time and date stamp be made and that it's also done in a fail-safe mode. Dupline Safe fits that. We just put a system in at the Denver International Airport, and there's a phase 2 going in there. We did one at San Francisco, SFO. So it's a nice market. And if I don't know if you have salespeople that call on that type of account, because I know you're heavy process, but the airports are all seeing aging infrastructure, and this is federal money, and my guess is they all have a need for this, and we're happy to service this through our distributor partners. Anything we can, it really works. It works better for us too. Excuse me. So it can also be used for as a, let's say, an annunciator system. If you have an older factory, whereas it might have 4 different makes of safety equipment, it could have pills and Schmerzel and Omron SDI, all of these at different areas for manufacturing and assembly. With a SIL 3 rated system, we can pick up those safety issues and concentrate those into one bus system and bring those back to a central location. So instead of having to worry about integrating multiple brands and makes, we can be that integration. We can do that. Also, I mentioned aggregates. This is pulp and paper for chip mills. They have the same requirements. Here you see the rope. This is a pull cord switch down the side. If this thing is really long, it's really a problem because nobody knows where it was pulled. Any questions so far? I want another application, and when these show up, when detention centers buy, they usually come out of left field, and they're usually a lot of money. So we have been in this market for almost 20 years now. To give you an idea, there's over 2 million people incarcerated in the United States. It's incredible, but it's a market that continues to grow. And right now, there's no money to build more jails. So there's a lot of refurbish going on, especially as our level and our rate of incarceration. Did I spell that right? I did. So that just kind of sets the stage. But basically, our primary application is for door controls. In a cell door, whether it swings or it slides, they have door position switches, which send a signal to a panel through a PLC, whether it's open, closed, or secure. On a ship, it's called dogged. That's where they give it one more twist. So, true story, this was developed in a lounge on a napkin. This sensor, I had this guy over, a designer from Denmark, and I took them all out to dinner, and they were sitting there having beers, and after 5 minutes, we had nothing to talk about, and we're all getting these awkward looks. So I finally said to the guy from the detention company, I said, why don't you tell our designer what a perfect solution would be for you? So he proceeded to draw the lock pocket module, size, the relay it would carry. This has a really beefy relay. It needs to have supervised I/O. So I forgot all about it, and 6 months later, I get a data sheet and a sample says, here, we made this module, and it became an immediate success in the detention industry. And it has enough relay that if a signal sent to open a door has an 8-amp relay that will drive a lock solenoid. That's all you want to do. But it also has a tamper setting built in. This is a little internal supervised I/O, so that if the module comes offline, either from natural causes or tampering, it sends an immediate signal to the PLC. So it meets all of the specs, and the application is door control. It's perfect for that. But in a detention center, they also have circulating audio, and they put duress stations like this inside of the cell. I guess theoretically, if your cellmate is beating your head in, then you can go and push this button and it calls the guard. Well, this is really wire intensive, but with Dupline, we only use 2 conductors, and all we're doing is sending a signal to an audio relay. So circulating audio got really cost efficient to do with this solution. So that's another one, circulating audio. The other was door control, but we've also done some perimeter security. They have ultra sensitive sensors that are all along the perimeter. There's very expensive systems made by companies that just do that, like Stellar. That's a kind of a tongue twister. But Dupline works fine for that because it has the long distance, it can operate outside, and we just tie an input module to their sensitive sensor. So that's another one. So we have perimeter, we have door control, and we have circulating audio. Okay. And another, let me make sure I'm good on time. I think I'm fine. We have recently, in the past 2 years, developed a platform that has brought us into the 21st century, and it's our universal web platform. It's amazingly flexible, and you can manage 5,000 signals with this from a single device. It's a number 2 DIN, which means it's roughly the size of a business card. Up to 150 different devices that we make today can be connected and controlled by the UWP. And for Modbus devices like energy meters or card readers or sensors with Modbus, each one will handle up to 128 Modbus RTU devices. And then 7 networks deep. So it's a heck of a system. It has no software to buy or to upgrade or to subscribe to. It has a built-in web server, which gives it a web browser and an interface. So you get to this from your Chrome or your Firefox or Internet Explorer. The data is yours. The only thing we ever update is the firmware, and that's an opt-in. That's an opt-in solution. So let's take a short look at this. First, it connects everything together. Traditional Dupline. BACnet for building automation. I don't know if you encounter BACnet, but if you're involved in any level of building automation, it is the standard. Smart Dupline, like our parking guidance. Modbus TCP/IP, which is almost a de facto standard in the world. Energy meters. It also has because it's also a web service, it does a full push-pull with multiple file transfer protocols, and it has MQTT. So it's Amazon AWS approved, and it's Microsoft Azure certified. So it's an edge controller, if you're into such things. It's also a dolly, which is a lighting platform, and it has a web app that's kind of cool too. That's where you do your report generation and the sort. So how did we come to this? Going all the way back now, everything you pick up now is Industry 4.0. So it's the fourth industrial revolution. Most of us started our careers in the third industrial revolution, except I feel mine was back here sometimes. But I didn't realize this, but the first automation happened in the late 1700s. That's amazing to me. So at the time of even before the French Revolution, at the time of our revolution, we had automation. But this is where we are today, and everything's based on cyber physical systems, connectivity. So how did we get to that point? Well, we all have seen, everybody has their own version of the automation pyramid, and you guys have multiple lines. I'm sure you've seen the automation pyramid from a lot of the companies that you distribute for. But the classic automation pyramid, you have the device level, which is where you have sensors and actuators and things that Carlo Gavazzi has been very happy to deal with since 1931. Then you move up to the control level, which is where PLCs hang out, and then the SCADA level. But the problem is each level can only communicate up or down one level. That's it. Well, as we move towards Industry 4.0, now the control level has moved into the edge level, which means that you can have multiple edge controllers communicating downstream and upstream, but each level can communicate horizontally and vertically with all the different levels. So you can have an intelligent device, maybe on IO link, communicating with a cloud device, if that's what the application calls for. You'll still have PLCs in the edge because it's also the control level, and you'll still have that hierarchy if it makes sense. However, sometimes it doesn't make sense because all you're trying to do is share status with the cloud. So this is where everything's moving. And when I talked about the CPS or cyber physical level, everything is connected to everything. And that's really what Industry 4.0 and the industrial Internet of Things, that's where it's at. And that's what this type of product, which is an edge controller, takes us. So when we look at the different cyber systems, they're developed now for transportation. We see a lot of industry IoT, if you will. It's developing in healthcare, and we also touch heavily on the smart grid with our energy products. The thing is, as part of Industry 4.0, all of these systems will need to communicate. Self-driving vehicles, self-driving delivery trucks, automatic drones. I mean, it's just unreal where this is going for good and bad, but we're going to be a part of it. You know, we want to do more than just be a sensor company. So let's look at this UWP 3.0. It has a web app, like I mentioned, so you get to things through a browser. It has a configuration tool that is freely downloadable for configuring the UWP. But then the subsystems. Over here, this part that's cut off is a parking guidance. We also have energy management and data acquisition. We have full lighting and building automation control. And this device, like I say, it's very small. This on a screen, it's almost actual size. It's a number 2 DIN, as I mentioned. And it is a Linux PC, is what the UWP is. It has an Ethernet, standard Ethernet port on top, and it has a standard size USB port on the top. Now, on the bottom, there's 2 separate COM ports, both RS-485 that can handle 64 devices each. Now, if you're a communications guy or girl, lady, also COM1 can be made to be a slave. So this can be a master or a slave device. So it can actually be the head-end controller. And we've been spec'd by the state of Oklahoma Department of Corrections to actually handle the logic for a detention center. So the PLC's gone on that job, and this will replace it. So that's kind of cool. And then we like our LEDs, and we have full LED indication for the status of the ports and the status of the bus as far as the communications go. So it's a neat little product. So we have the main unit, and for example, I'll use energy meters. COM1 master slave, COM2 slave only, but we can also access, if we're using Ethernet IP or Modbus TCP IP, we can connect through this Ethernet port. Also, data pushing up, which makes it an edge controller, say to Amazon or Microsoft, has multiple protocols that can be used, and that all happens through this Ethernet port as well. Sorry for the graininess, it's the best picture I had, but this has a high-speed bus for connecting network controllers. There is a port here, but also if the physical locations won't allow it, the UWP can be connected via screw terminals, but it does have a high-speed bus, and up to 7 individual networks can be connected to a single UWP. And by 7, these are hundreds of addresses each because they're Dupline, and this can be a lighting controller. This one can be a parking garage. This one can be another lighting controller. This can be doing energy and on and on. And then you can have multiple networks, either wired or wireless. So we're now pushing into thousands of monitored variables, thousands. So imagine you could deploy this for an enterprise, for a city, for you know, something large scale like an amusement park. It's really, the sky's the limit on this. Now you access it through a graphical user interface with the built-in web browser. These are a few screenshots I have. You can log on and look at these, but you can design your own screen. So this is somebody's interpretation. It's basically giving energy usage over a period of time. You can also build widgets, quote unquote, to where you decide on the groupings of the variables. Here's another one, energy usage over time. Another representation of that with adding in yearly and total. So it's a very powerful tool. And we have a demo site too. I don't expect you to write that down, but so in the future, what's coming? I think the biggest move is wireless. And I mentioned early on that we have a LoRaWAN. You can say all of that, but basically it's going to bring our products to the Internet of Things. And LoRaWAN is it's a low power wide area network that can bring together different data points. For instance, let's imagine that we have a county-wide stream monitoring stations, that maybe you have a river, maybe you have a lake, maybe you have wells, and these all need to be monitored for the health of the water. You can have air pollution monitoring. There's now transponders that will fit on a pet's collar, so you have lost pets. You can do automatic water and electrical meter reading. That's what LoRaWAN is, and we're able to embrace that. And as you can see, healthcare, industrial control, I won't read them all to you. Supply chain logistics. A lot of the home delivery now. I'm seeing Walmart's into it, Amazon's been into it. So LoRa is the protocol, and we are members of the LoRa Alliance, if that means anything. But it's so much in its infancy. I'm stepping into it carefully. So in summary, Dupline is an extremely versatile platform. There's over almost 200,000 installations globally. And it's probably one of the most unique bus systems I've ever had the pleasure to work with.